Hello everyone, let's look at some numericals based on capacitors. Example 1 says a parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. What will be the capacitance if the space between them is filled with a substance of dielectric constant 6? That's first part of the question. Second part says also calculate the charge stored by this capacitor when it is connected to a 1 kilovolt battery. So let's do it. So what is given is the capacitance with air between the plates as a capacitance of 8 picofarad. So the capacitance when the air is between the plates is given as 8 picofarad. The first part says what will be the capacitance if the space between them is filled with a substance of dielectric constant 6. We learned in theory class that the capacitance in presence of any dielectric constant is equal to dielectric constant into capacitance in free space. So it will be 6 into capacitance in free space is given as 8 picofarad, which is 8 into 10 power minus 12. That is equal to 48 into 10 power minus 12 is equal to 48 picofarad. That is the first part of the question. Second part says also calculate the charge stored by this capacitor when it is connected to a 1 kilovolt battery. So we know that from definition of capacitance, Q is equal to C into V. It is the capacitance when a dielectric is filled between the plates, so it becomes C for the dielectric medium. That is equal to 48 into 10 power minus 12 into 1 picofarad. 1 kilovolt. 1 kilovolt is 10 power 3 volt. That is 48 into 10 power minus 9 coulomb, which is same as 48 nano coulomb. So this is the required answer. Example 2 says 3 capacitors, each of capacitance 9 picofarad, are connected in series. There are 3 parts to the question. Part 1 says what is the total capacitance of the combination. Second part says what is the charge on each capacitor if the combination is connected to a supply of voltage 1 kilovolt. Third part says what is the energy stored in the combination. So let's look at one by one. So there are 3 capacitors of capacitance 9 farad each, which are in series. So let's draw them first. There are 3 capacitors, each of value given as 9 picofarad. So all these capacitors would be connected to a battery whose voltage drop is given as 1 kilovolt. So here V is given as 1 kilovolt. Let's call each one as C. So question says find, the first part says find the equivalent capacitance. We learned in theory class that for a series combination, if each capacitors have same value, then the equivalent capacitance is given by the capacitance value by number of capacitors. So in this case, each one is having a value of 9 picofarad. So it will be 9 into 10 power minus 12 by 3. So 3 ones are 3 threes are. Therefore, the effective value would be 3 into 10 power minus 12. That is same as 3 picofarad. So this is the part A. Part B says what is the charge on each capacitor. Now here what you can do is, if you want to find charge on each capacitor, we can replace this circuit by its equivalent circuit, which means we can put a single capacitor to the same battery such that this capacitor draws the same amount of charge, which is Q in this case. And this capacitance should be the equivalent capacitance Cs, where the voltage is equal to 1 kilovolt. So in this case, Q would be Cs into V. Cs is 3 into 10 power minus 12 and V is 10 power 3 because it is kilovolt. That is 3 into 10 power minus 9 coulomb or 3 nanocoulomb. So the charge on each capacitor plate, because by definition a series combination means that each capacitor will have the same amount of charge. So this charge Q is what will go through each capacitor plates. Therefore, the charge on each capacitor is 3 nanocoulomb. Part C says, what is the energy stored in the combination? So its energy in the combination, we learned that the energy is given as, we can write in many ways. We can write this as half into C into V square. Now it is the energy across the combination. So you can do in two ways. You can find what is energy across each capacitor and add it, or you can find across its equivalent capacitance. So in such case, what happens here is, so it becomes Cs, that is half into Cs would be 3 picofarad, which is 3 into 10 power minus 12 into V square. V square is 10 power 3. So it becomes 10 power 3 the whole square, that is 1.5 into 10 power minus 12 plus 6, that's 1.5 microjoule. If the question says to find the energy across each capacitor, it will be 1/3 of it. Example 3 says 3 capacitors of capacitances 2 picofarad, 3 picofarad and 4 picofarad are connected in parallel. Even here there are 3 subparts to the question. The first subpart says, what is the effective capacitance of the combination? Second part is, determine the charge on each capacitor if the combination is connected to a 100 volt supply. And third part is, calculate the energy stored by the combination. So let's do it one by one. The first thing is, let's draw a diagram for this case. There are 3 capacitors. And then these 3 are connected to a battery which provides a supply of 100 volt. Some charge Q would be drawn, and this charge Q divides into 3 parts. When charge Q comes to the point A, the charge Q finds 3 possible parts. So charge divides. Let's call the charge as Q1 in this capacitor, Q2 here and Q3 here. The values are given as, say, 2 picofarad, 3 picofarad and then it's 4 picofarad. The first part is, what is the effective capacitance of the combination? For parallel combination, the effective capacitance would be just simply adding each capacitance value. So in this case it will be 2 plus 3 plus 4 into picofarad, because each has same unit. That will be 9 picofarad. So this is the equivalent value. It means that we can replace this combination, we can replace these by a single capacitor such that the capacitor value is equal to 9 picofarad, and even this would draw the same amount of charge. So if it's 100 volt, even this would draw the same charge called as capital Q. That's part 1. Part 2 says, determine the charge on each capacitor if the combination is connected to a 100-volt battery. So what you can do in this case is, we can do in two ways. We can find the total charge coming here and divide by using the proportions, or in a more simpler way, in case of parallel combination, the charge across each would vary, but since these are in parallel, the voltage drop across each would be same. It will be 100 volt across each of the capacitor. So with that in mind, we can do it using the second method. So the second part is to find the charge across each capacitor, where Q1 is equal to C1 into V. It is 2 into 10 power minus 12 into 100, that is 2 into 10 power minus 10 coulomb, or we can write this as 0.2 into 10 power minus 9 coulomb, so it is 0.2 nanocoulomb. It is better to write the charges or capacitance in terms of a multiple than keeping the power as it is here. This looks much better. And then across the second capacitor, we'll call Q2 is equal to C2 into V. It is 3 into 10 power minus 12 into 100. That will be 0.3 nanocoulomb. And then across the third one, it will be C3 into V. That is 4 into 10 power minus 12 into 100. That will be 0.4 nanocoulomb. So these are the charges across each capacitor. Third part is calculate the energy stored by the combination. Again here, you know what is the equivalent capacitance, you know the voltage, so we can do directly also using the form. The form is U is equal to half C into V square. It is for the entire combination, so it becomes CP. It's half into CP is 9 into 10 power minus 12 into V square. Now V is 10 power 2, so it becomes 10 power 2 the whole square is equal to 2 ones are, it goes in 1, this is 4.5, so it's equal to 4.5 into 10 power minus 12 plus 4, that is 4.5 into 10 power minus 8 joule, or 45 into 10 power minus 9 joule, or 45 nanojoule. So this is the required answer. Example 4 says, obtain the equivalent capacitance in the network. Also calculate the charge and voltage across each capacitor. So C1 and C2 each is equal to 100 picofarad. C2 and C3 each is equal to 200 picofarad. As given here, let's find out whether these are in series or parallel combination. To understand this, let's put a battery here. It's already given as the battery points. Let's call this as point A and then point B. So if we look at this as point A, this is point B, and if point A is taken as positive terminal, then charge would leave from here. When charge comes to this point, it finds two possible paths. Some part of charge goes here and some part goes here. Now let us call this charge as Q1, this as Q2, or rather we call this as Q1, this is Q2. So charge Q1 flows to capacitor C1, while charge Q2 flows to C3. After crossing C3, it again flows to C2. So here C2 and C3 would be in series combination. Since the charge divides here, this effective of C2 and C3, which is in series combination, is in parallel to C1 because charge divides here. So in such numericals, do it step by step. First find the equivalent and do it from here. Again here, at this point, the charge would combine. So charge would combine here, and charge what flows would be Q1 plus Q2, which is same as Q itself. So first we'll find it step by step. The first step is to find the equivalent of C2 and then C3. C2 and C3 is in series, so the equivalent of C2 and C3, these are in series combination, and C2 and C3 has same value. Therefore, this is equal to any one value, which is 200 picofarad by 2, because there are two capacitors in series. It's equal to 100 picofarad. So we have broken this first step. So we have one capacitor C1 and one equivalent here. Across this we have the battery connected. We'll first do this two combinations. This is C1, this is C2, 3. Just the name given to it, nothing beyond the name. C1 and C2 are in parallel now, so they'll add up. So I'll call this as C dash. So C dash is the equivalent of C1 and this equivalent. Since they are in parallel, they'll add up normally. That is, it will be just the sum of these two. It will be 100 plus C1 is 100 plus 100, it's equal to 200 picofarad. Now what we have is, we have equivalent of all these three, which is one capacitor to a battery, and we have one more capacitor here. So this value here was 200 picofarad, and this capacitor here is C4, and value of C4 is 100 picofarad. So it is 100 picofarad across a 300 volt battery. These two are in series because whatever charge leaves from the battery, the same charge flows everywhere here. So this equivalent of all the four I call as C1. So C1 is the entire equivalent, that will be equal to these two in series. So we have seen in theory class that if two capacitors in series, then it will be 2, their values, which will be C dash C4 by C dash plus C4, that is C series is equal to C1 C2 by C1 plus C2. There's no 2 here. This will be C1. So we'll do it now. It will be 100 into 200 by 100 plus 200. It's equal to 200 or into 100 by 300. There's a multiple of 10 power minus 12. So into 10 power minus 12. So from here, 2 gets cancelled. So what remains from here is C1 is equal to 200 by 3 picofarad. So this is the required equivalent combination. That's the first part of the question. Second part says, calculate the charge and voltage across each capacitor. We'll first find the charge across each capacitor. Now let us find a charge coming out of the battery. So let us call that charge as some Q. If charge Q comes out of the battery, it divides into two parts, where a part Q1 goes here and a part Q2 goes here. So let's first find out what total charge itself is. In this case, we have found out the equivalent capacitance, which is 200 by 3 picofarad. So the entire combination, the charge which comes out is called as Q, that will be C into V, which is C1 into V is 300. That will be 200 by 3 into 300 into 10 power minus 12. So 1s are, this is again 100 times, that is equal to Q is equal to 2 into 10 power minus 8 coulomb, and it will be 20 nano coulomb. This is what is Q. Now this charge divides into equivalent parts. Now from here, this charge divides into two parts. Now this value and this value is same, because equivalent of C2 and C3, which is called a C dash, that was 200 picofarad, and C1, C2 and C3 was, that is equivalent of C2 and C3 was 100 picofarad, and also C1 is same value only. Therefore, this charge divides into two parts. That is, look at this. A charge coming from this point is, say, Q. A part of it, Q1, goes here, and a part Q2 goes here. And in this case, the equivalent of these two, that is equivalent of C2 and C3, was 100 picofarad, and also C1 is same value only, which means the charge finds two equivalent branches and divides into half. So one half goes here, one half goes here. So out of this 20 nanocoulomb, whatever we found out here, which is Q, it divides. So charge going here would be 20, that is charge coming from battery is 20, it divides in two parts. So here Q1 would be half of it, which is 10 nanocoulomb, and Q2 also be equal to 10 nanocoulomb. The charge divides here. Now these two charges would combine at this point. Therefore, charge going here would be sum of these two, which is 20 nanocoulomb. So charges would be 10 nanocoulomb and then 20 nanocoulomb. Last point was to find the voltage across each capacitor. Now this I'll use exercise. Use the form Q is equal to C into V, or V is equal to Q by C, and solve and find it out. Example 5 says 4 capacitors, each of capacitance 400 picofarad, are charged each to 100 volt and they are connected in parallel. Calculate the energy stored in them. Example 5 says 4 capacitors, each of capacitance 400 picofarad, are charged each to 100 volt and they are connected in parallel. Calculate the energy stored in the system. So we know that in case of parallel combination, the equivalent capacitance is equal to C1 plus C2 plus C3. In this case there are 4 capacitors, so it will be plus C4. Now since all of this are of same value, we can say Cp would be 4 times C. That will be 4 into C is given as 400 into 10 power minus 12. That is Cp is equal to 1600 picofarad. Question says calculate the energy stored in the system. So energy we can write it as half C into V square. In this case it is across the entire combination, so it becomes Cp into V square, that is half Cp would be 1600 into 10 power minus 12 into V square is 10 power 2 the whole square. So it is 2 1s are 2 8s are, or 800 times. So it will be 8 into 10 power minus 10, that is this factor would be 10 power minus 10 into 10 power plus 4. So it becomes here plus 4, that is equal to 8 into 10 power minus 6 joule, or 8 microjoule. So this is the required answer.